On November 14th, 2023, Voyager 1 suddenly fell silent, sending back only meaningless binary data. The spacecraft that had ventured beyond the solar system seemed lost forever. The cause: memory failure in its flight data system, risking permanent communication loss. But the team refused to give up. They made the bold decision to reallocate code to other memory areas. This process began April 18th, 2024, with great risk. The signal took 22.5 hours to reach Voyager and the same time for a response. Every attempt was a step into the unknown. Just 2 days later, after months of intense work, something incredible happened. Voyager 1 re-established contact. In the late 1970s, a rare event occurred. A planetary alignment happening once every 175 years. The gas giants lined up, creating a unique opportunity to study them in one mission. NASA seized it. Voyager 1 launched after its twin, overtaking Voyager 2 thanks to a faster trajectory, 38,000 miles per hour versus 34,360 miles per hour. Just 13 days after launch, it captured the historic photo of Earth and Moon from 7.2 million miles away. In 1979, both probes reached Jupiter, revealing unknown rings, discovering 3 new moons, and capturing detailed images of its largest satellites. They confirmed Ganymede is the solar system's largest moon, not Titan as previously thought. They discovered Europa's smooth ice surface riddled with cracks, giving origin to the subsurface ocean hypothesis. Scientists had their first close-up view of Jupiter's Great Red Spot, a centuries-old storm larger than Earth. Using Jupiter's gravity for a speed boost, both probes reached Saturn in 1980 to 1981. This marked a turning point. Initially planned for just 4 years to study Jupiter and Saturn, NASA designed trajectories allowing potential exploration of other planets. Voyager 1 was directed toward Titan, sacrificing its ability to continue, while Voyager 2 was sent onwards to Uranus and Neptune. They delivered detailed Saturn images, revealing hundreds of narrow, intricately structured rings. 4 new moons were discovered. Mimas was particularly interesting, dotted with craters including the massive Herschel crater, giving it a striking Death Star resemblance. Titan harbored an unpleasant surprise. Its atmosphere was opaque to visible light, but analysis showed Titan's temperature was near the triple point where methane behaves like water does on Earth. Saturn's gravity significantly accelerated Voyager 1, making it the fastest spacecraft in history. Voyager 2 continued to Uranus, reaching it in January 1986, coming within 50,600 miles of its surface. Scientists were surprised. Uranus was vastly different from Jupiter and Saturn. While gas giants are 90% hydrogen and helium, Uranus contains these only in its atmosphere. Beneath lies an ocean of water, ammonia, methane, and hydrogen sulfide with a rock and ice core. Planets of this type were named ice giants. Uranus turned out to be the coldest planet in the solar system, even colder than Neptune. Voyager 2 moved to its final target, Neptune, reaching it August 1989. The only spacecraft to visit the 8th planet. On August 25, 1989, it captured the first detailed Neptune images, completing its grand tour. The planet appeared vividly blue, though later data revealed its true color is closer to teal. While Voyager 2 explored, Voyager 1 could only envy. After Saturn, engineers disabled significant portions of its instruments. But on February 14, 1990, from 3.72 billion miles away, it captured Earth as a tiny pale blue dot, just 0.12 pixels. This iconic photo became the last image ever taken by Voyager 1 before cameras on both probes were permanently shut down. Our cosmic travelers entered a decade-and-a-half calm, interrupted by an extraordinary event. On August 25, 2012, Voyager 1's instruments recorded a sharp drop in charged particles from the Sun and a rise in galactic cosmic rays. The spacecraft had finally entered interstellar space, leaving the region where the Sun's influence ends. Voyager 2 crossed the same boundary November 2018. The heliosphere, our solar system's unique bubble, extends about 11 billion miles from the Sun, formed by solar wind and ending at the heliopause. The Voyagers are the only spacecraft to cross this boundary. What they discovered sparked widespread interest. Previously, scientists believed solar wind gradually weakens farther from the Sun, but data showed solar wind doesn't fade. It reaches a sharp boundary where its influence ceases and interstellar space begins. The solar wind flows around the heliopause from inside, while interstellar plasma flows around it from outside. We determined the heliosphere's shape. On one side, it resembles a sphere. On the other, it stretches into a long tail. This shape isn't static. The boundary constantly moves. The heliosphere's surface is distorted by massive waves appearing at unexpected angles, reaching 10 astronomical units, 930 million miles. By studying Voyager data, scientists discovered the heliopause underwent rapid changes over a very short period, possibly explaining why the time difference for the two probes crossing was 6 whole years. Temperature and density of solar wind near the heliopause defy explanation. Astrophysicists expected the slowing of solar particles by interstellar radiation would cause a sharp increase in temperature and density. This did happen, but measured values were 10 times lower than theoretical predictions. Where this energy is lost remains unclear. Data revealed interstellar space consists of denser, colder plasma, while plasma near the solar system's boundary is hotter and less dense. These two types interact, particles from solar wind and interstellar wind mix, creating a boundary layer. But interaction doesn't end there. Shock waves emitted by the Sun can pass through the heliopause into interstellar space, creating disturbances similar to those caused by supernovae. Scientists also learned the interstellar magnetic field is 2 to 3 times more powerful than previously thought, meaning interstellar particles exert 10 times more pressure on the heliosphere than expected. Throughout their journey through interstellar space, the Voyagers continued sending signals, transmitting data about instrument status and locations. But in 2012, Voyager 1 unexpectedly transmitted a strange signal while 14.6 billion miles from Earth. It began transmitting chaotic data about its position, sequences of zeros or the number 377. This mysterious signal puzzled scientists. Later, it was discovered to be a malfunction related to the spacecraft's altitude control system. Although it was still possible to control the spacecraft manually, Voyager 1 lost precise awareness of its position, likely due to cosmic radiation affecting navigation. NASA engineers successfully resolved it by transmitting telemetry through another onboard computer. Another alarming event occurred when Voyager 1 went silent for an extended period, starting November 14, 2023, lasting 5 months. This was caused by corrupted code on one of its chips. To fix it, the team reallocated code to other memory sections. On April 18, 2024, the data transfer began. By April 20th, the team confirmed success. After 5 months, scientists restored communication with Voyager 1 and verified its functionality. These malfunctions remind us that our cosmic travelers' lives are near their end. NASA hopes the Voyager's instruments will function until 2025, after which a phased shutdown begins. In a few years, they'll lose energy needed to communicate with Earth, likely around the 50th mission anniversary. This will mark the final chapter. Even after losing contact, their journeys continue. They may witness many fascinating phenomena, though they can no longer tell us. Voyager 1 is moving away at about 3.5 astronomical units per year. It's currently heading toward the constellation Ophiuchus. In the year 40,272 to 38,200 years from now, it will approach within 1.7 light years of a star in Ursa Minor called AC plus 79 3888. Voyager 2 is leaving at about 3.1 astronomical units per year. Around 40,000 years from now, it will approach within 1.7 light years of Ross 248 in Andromeda. Currently, Voyager 1 is approximately 15.5 billion miles from Earth. Voyager 2 is 12.4 billion miles away. Although they passed the heliopause long ago, it's not entirely accurate to say they've fully exited the solar system. Scientists believe the solar system encompasses everything within the sun's gravitational influence. The final frontier is the Oort cloud, a hypothetical spherical region serving as the source of comets. The estimated distance to the outer edge ranges from 50,000 to 100,000 astronomical units. Voyager 1 will take approximately 300 years to reach the inner edge and possibly 30,000 years to traverse it, marking its ultimate departure from the solar system. If on their distant journeys the spacecraft encounter extraterrestrial life, they're equipped with messages, a phonographic record on a gold-plated copper disc. About 3/4 of the recordings are music. The disc contains greetings in various languages, messages from the U.S. President and UN Secretary General, sounds of Earth, human voices, whale songs, brainwave recordings, and more. Plenty for aliens to occupy themselves. But if the Voyagers are never discovered, they'll continue drifting peacefully through the dark, cold, interstellar void, a symbol of humanity's quest for knowledge and a reminder to the universe of the ambitions and hopes of inhabitants of a small, pale blue dot.